Okay, let's get started. So in order to understand strings, you have to start with characters because a string is a sequence of characters. And in particular, in C, a string is just not a sequence of characters. It's a sequence of characters with it's a sequence of characters with a null character at the end. This is what is called as a null character. And each of these characters, they are represented in the computer in the form of a, every character has an ASCII value, and that ASCII value is what gets represented inside the computer. Okay, so let's write a program and try to understand strings. So that would be so you'll see null character means it's a special character whose ASCII value, we will see what's the ASCII value of the null character, printf. So we are now looking at the char data type. So let's declare a variable char ch and printf %c %d %x. ch. So now we are %x2 is to print the value, some value in hexadecimal format. Okay, so now you can see that you know, in the memory, if you see in memory, the variable ch, it is allocated memory somewhere. Okay, so what happens is so when we say ch is equal to a, what the variable a has an encoding. The variable, sorry, no, not the variable a. The character a has an encoding, and it is encoded. It has some value. Its value, it's represented using this value 97. And so in the hexadecimal form, this 97 is nothing but 61. In binary, it will be 0110 000 01. So eventually, if you go and see in the memory, this is what will be present. So this is the 8-bit pattern that will be present in the memory associated with H. Just to indicate hexadecimal convention, it starts with 0x, so that's the convention. So if you go look into the memory associated with the variable ch, the bit pattern that is present there is 0110, 3 zeros followed by 1. This bit pattern you can know when you interpret it as a character, you get A. When you interpret it as a decimal number, you get 97. When you interpret it in the hexadecimal form, you get 61H. And in the binary, it is nothing but whatever the bit pattern you are seeing on the screen. Does it make sense? Are you all with me? So in memory, it is stored in the binary equivalent of the ASCII value, exactly. So very good summarization. So that is a bit pattern of 61 or 97. Huh? Both are same Patanjali. What is the hexadecimal representation of 97? 61, right? So now let's see an interesting, let's try to write an interesting program. So char CH is equal to A. I'll just comment this code. Now what gets printed on the screen when I compile this? It will not run, huh? It will run. Why not? You see, we print from A to Z. And %x means print it in hexadecimal form. When you increment a character, plus ch means whatever the value associated, you treat the value that is present in that memory here and you increment it by 1. CH, you know, when CH contains 97, so CH++, what does CH++ means? So CH++, so 97 is there, you increment it by 1, you get 98, and 98 is ASCII value of B. So you print B. ASCII is a standard, it is same across ASCII. Yeah, any representation, it's in no, all characters, they are represented in ASCII form. There's an ASCII encoding. Yeah, CH is in some sense, when we do increment, it is typecasted. It's not typecasted actually, it will. How is CH a character or a? If you look at the binary pattern, if you look at this binary pattern 0, so let's say if I don't, if I hide the top part and if I just show you this, by looking at the binary pattern, can you tell is it an integer, is it a character, or is it just by looking here? You cannot say anything, right? It can mean anything. It can mean your house number, it can mean A, it can mean. So a bit pattern by itself, it doesn't have any meaning. A bit pattern, what is the semantics that we associate is what matters. So what happens is this same bit pattern in the first case, in the second case, in the third case, all of them, they are pointing to the same because we are using CH. In the first case, we interpret it as a character. When we interpret it as a character, so this bit pattern corresponds to A, so A gets printed. When we interpret it as a decimal number, we get 122. And in the third case, when we think of it as a hexadecimal number, and this is what we get. Okay. Are you all with me here? So now, let's do one thing. So we will have So let's focus here. Some interesting questions are being asked. For the time being, I will, let me run this program here. CD CP21B GCC print .c .out. Now you can see that we are printing small a ASCII value, big A ASCII value. What is the difference? 97 minus 65, it is 32. Okay, so you can see, the difference is uniform because the ASCII values of capital A to capital Z, they go from 65 to 90, and the ASCII value of capital A to capital small a to small z, it goes from 97 to 122. Okay. And we are not, so we know, I know this already before, so because of that, I am just iterating on the small z. Okay, and the termination condition, just using the termination condition is based on small z, on the small character, because in this particular case, the logic works. Does this make sense why I am having iteration on only the small? We are defining here, no? Big CH. In the for loop, we are defining big CH. Appar has this question, so if you just write CH is equal to A, then what will the compiler think? That A is a variable, so it tries to find a variable A, and it says there is no such variable, and it complains. So what happens is, so this is what is called as character constant or character literal or character constant. Why I don't have to write char big CH is this char is applicable to this CH and big CH. Okay, so now we will move to the next idea, that is how to work with strings. So let's say Mag's name length 20. So now we are defining an array whose so we are defining an array of 20 characters. We are defining an array of 20 characters. And then we say printf enter your name and then we'll say scanf %s name printf Is it a good idea to use only keyboard? It's a good idea to use. So let's run this program and see. Speech to text is better. Let's give Rohan. Okay, hello Rohan. So it's working. Okay. So what happens? Scanf requires number one. So if you look at when you enter your name, so here, no, so it gets stored like this. This is null character. This is what you get. It will be garbage, and there will be, and this is the base address. So this is the base address of the array. So when you want to pass, what is the parameter you want to pass to scanf? You want to pass the base address of the array. Yes or no? You want to pass the base address, otherwise you will not be able to, scanf will not be able to read the string and store it in the memory associated with name. So here base address. And base address of the array is contained in the name, right? So because of that, you don't require address of name. Are you all with me here? Similarly, printf also needs to know the base address. Because once it knows the base address, it keeps reading printf. And once it encounters this null character, it knows that the string has end and it will stop. Okay. The points I mentioned here, I hope you are with me. And let's go here. GCC print str.c. So right now, what is contained in that array of that name array? It is random characters. Okay. So garbage values. We cannot say this. It will contain this or that. We cannot say anything about that. All right. That /0 means it's like null character. It's initialized to 0, and 0 is nothing but null character. So because of that, yeah, it's anyway. Don't worry about it for the time being. Let's do the scanf. When we do the scanf, enter your name. So let's say, okay. Now you print name. You can see white space is not same as a null character. So you can see Anika followed by null character. This is not guaranteed. This can be anything. But what scanf guarantees is whatever that we have typed in, that will be read, and after that null character will be present. Null character means 0. That value of null character is 0. Let's say, don't worry, just think of it as 0. Why 3 zeros? It's just a representation. So it's nothing but 0. Just think of it like that. Okay, now it is printing that. So now let's run it again, and so now let's come out of this program and we'll run it here. We'll run it here. gcc print str.c dot a dot out, and let's say if I write yeah, so scanf doesn't like Roy, so it just read Anika. So I'm sorry. So the thing is, scanf keeps reading till it gets a space at that. Why, I don't know why scanf doesn't like Roy. No, you ask scanf. So yeah. So anyways, so the thing here is that the space is there, right? Once it hits a space, it will stop reading. It will stop reading the string. So if you want to read strings with space, we'll figure out something. Okay, not now, but in so for the time being, if you just use scanf with percentage, when it hits a space, it will stop. Space is a character, but scanf, by the convention that scanf follows for with percentage format specifier is you keep reading until yeah. So, but what happens is here, this space followed by Roy, it is still there in the input keyboard buffer. So when you use the next scanf, that scanf will will read Roy. It will ignore this space and then it will read Roy into the next scanf. Are you with me here? How scanf works? Okay, there is a keyboard buffer. Percentage, what it does is it keeps reading the keyboard buffer. Once it hits a space, it will not consume any more input, and but the remaining input is still there in the keyboard buffer, and the next scanf it will pick up this part. Why didn't print that is the point, right? So when we do printf, how is it stored inside? How is it stored? It is stored in the memory. If this is your memory, here null character. So what happens is it keeps going down, and when it hits a null character, it will stop. So this is the termination. This is the important point. Okay. So now let's try to do what, let's try to simulate. So let's try to do this. For I is equal to 0, name of I not equal to null plus I, printf %c /t name I. Okay. So let's see now if we gcc print str.c. What is the return value of scanf? I think even after the exam, even after getting marks or losing marks, if you're still asking me what is scanf, try it out, right? So the one important thing, guys, I want you to learn is the read man page. You write a small program. Sardak, you write a small program and look at the return value of scanf and see what it prints. You can do that, now. It returns one, but I want you to experiment, no? I want you to write small snippets of code, read man pages, do things, and then figure out, okay? So that's the process to learn. So I want you to be self-sufficient, not dependent on me. So okay, this time let's give Sarthak. Okay. So now we see expanded form of Sarthak in the second line. Or tabbed Sarthak. Okay. So you see the logic for here, what we are doing, how we are so now we will see one more line, one more way of white space. White space between Sarthak, because we want to expand Sarthak. So now we will work in a different way now. So char ch pointer is equal to name. The code that we are writing, very small chunks of code, but they are very, very important. So when you see the loop on line 19, ch pointer, it's a pointer, it's a variable, it contains the address of an object, which is of type character. Does it make sense? Line number 19, ch pointer, it's a variable, we are initializing it to an address, and it's the address of a object which is of type pointer. Okay, so we have our ch pointer variable here. This is ch ptr, and then so let's say /t is tab. Tab means a sequence of characters. /0, it's what is called as a null character. And like /n, it is also, these are all, there are many escape sequences. /n, /t, /0. /0 is also a special character which is called as null character. So why you get /0? So when we put the a, now this is a string. This becomes a string. This is a character. This is a string. This is string. This is character. Okay. So now, here is our. This is our name. This is name. This is name 0. So on line number 19, let's say the address of this is something like AA. Then this AA will be present here on line number 19 because of chptr is equal to name. Does it make sense? Now printf, what will printf will do? Whatever the address present, we go to that memory, we read a byte of data and print it in the form of a character. Are you all with me? And after that, we increment the character pointer. When we increment character pointer, it gets increment by 1. This is called as pointer arithmetic. Okay, we are incrementing the character pointer by 1. It gets incremented by 1. So after the loop, after AA becomes, let's say, instead of AA, so let's call it as A1. It's easy for me to. This is A1, this is A1. So after one iteration of the loop, CH pointer will become A2 and the CH pointer will point to the second character. Don't think complex combinations of C, just it will run you crazy. You try out and figure that out. But are you all with me on loop 19? See, in C, when you do some crazy, there are many crazy things you can do. They are good to trick you in the exam, okay, but they are not really useful in real programs. Do you understand? Like the question Vinkesh asked, it's so that kind of question is for exam. They are not in practice. We should not do all sorts of things like that. So initially the pointer points to the base address, yes, Purvi. And then you print and then again you increment the pointer so that it points to the next address. And you check if it's a null character. If it's not a null character, you enter the loop, you print, and you continue like this. Are you all with me? Yes, no? Does this make sense? So here, let's say we use %4C. Printf does not print null character. No. I'm using %10C. Okay. So who shall we expand more? Mahika. Let's use Mahika. Sorry. What does %10C will do? Let's go back here. ACC print str.c .a.out. 10 columns will be used. Yeah. Each character is printed in 10 spaces. Okay. So from here to here 10 spaces, from here to here 10 spaces. And I think if you use minus, what will happen? Left alignment. See, it is left alignment. From here to here 10 spaces, left alignment. Okay, so now there is one interesting question. So let's see, these are the two things. Yeah. Let me do one thing. I just copy paste this code and so what do I get here? If what will be the last output? Do you see what is happening in the last for loop in line number 24? Now let's see. GCC print.str.c .out. We are not printing address. It takes the base address of the string and it prints the whole string till it hits that null character. If you want the opposite, no, there is very simple now. I think, see, that's the reason. Yeah. So it's, why do we use, no, I just want to print some pattern. That's, so what is the address? This is the name. So M A H I K everything gone. A null character. So to printf, if you pass, this is name 0, name 1. If you pass to printf this, it keeps printing everything till it hits a 0. If you pass h to it, it prints everything starting from h till it hits the null character, so on and so forth. What is this address? That's all. Address of name I is the address of the ith element of the array. That's all. Did you get this now? Are you all with me here? That is the semantics. That is the semantics of printf with percentage format specifier. You want to print a string. You want to print a string. And if you want to print a string, you want to give the base address. But otherwise, if you want to print Mahika, how do you print it? You know, do you want to print M first, A first, H first, I first? You can do that, but it's but if you are working, if you want to tell printf, hey, I want to print this whole string, you just give the base address. What do you mean by need? Yeah, that's true. If you want Hika, we just give the base address. See, the base address, the thing is this. This and this are the same. Okay, because of that, since these two are the same, we are using this approach in line number 19. But if you want to print starting from here, we have to give address of base address of H. This is name 2. So if you want to print a Hika, we have to bring base address of name 2. We should pass as parameter here. Are you with me? If you pass name I gives the value at that. If you pass H, what will happen here? If you use, instead of using let's say, instead of using this, if you use name I, what will happen? Name 2 here. Name 2, if you pass here, what will happen? What is present at name 2? H will not be printed. So H will not, segmentation fault. Printf will go to that address. The ASCII value of H is, let's say, 100. Printf will try to go to address 100 and it tries to start reading a string starting from that address. But address 100, you may not have read permissions, and so the operating system will kill your process and you will become it will get a segmentation fault. Yes. Are you all with me now? Does it make sense? Yes, no, maybe, happy, unhappy? So this is correct code only. No? What is the correct code? We just want to print like this. This is correct code. No, here we are printing %C. We want, there is a difference between printing a character and printing a string. On line number 15, we are saying %C. %C means the character present at that location you want to print. You want to print, there's a difference between printing. If I want you to print a character, I just give you the character and you can print it. But if I want you to print a string, I will give you the address of my string, so that starting from that address, you keep on reading till you encounter a null character. Do you see the difference between %C and %S? When you use %C, you have to give the ASCII value of the character to print. If you give %S, you have to give the base address. Okay. So now if you want to print, now if you want to do the Mahika, if you want to print the other way, so what if we use 6s? See, it got printed in the. Okay. So if you want to have a little bit more fun, we can do one more thing also. What do you think will happen? You got a tower. Okay. All right. Poor Mahika. That's what will happen if you ask a question. Okay then. So now, what do we do? So can we write a program to sort a list of names? Can we read a list of names and sort them? Are you all up for it? Okay. Create a GitHub repo and share these codes. Not a bad idea. So we want to, yeah, I don't like this. This code I will delete. So we want to write a function which hash define max name underscore len 20 max array. Okay. So now we go to function main and we remove the loop version of the sort. We just keep it simple. Number of names, max number of names. So now I want you to understand this number of names. We have to write, yeah, read names. So what is happening here is, we are defining a 2D array of strings. Okay. So this is our 2D array. So first name, like for example, Akshat is there, row 0. Akshat followed by null character. Similarly, in row 1, this is Vrinda followed by null character. And then if you go down, so Ashmit followed by null character, like that. So some spaces could go empty in every row, it's okay. So if you want to, this is names 0. If you look at this one, so this is names 0 of this, we can call it as 0th row. If you want to get the address of this row 0, we can just use address of name 0, 0. And if you want to get the address of the string, you can have address of names 1, 0, that is row 1, 0th character, so on and so forth. Does this make sense? Are you all with me here? This is the basic thing. In general, if you want to access the string present in the ith row, we can just use the address of name set. Yes, no? I hope you're all with me here. So this is the basis for our work. So now let's go here. So char names. Remember, when we are passing two-dimensional parameters, the second parameter and read array, what did we use? The second parameter? Yeah, int. So actually we don't use in the read array the second dimension per se. So anyway, let's use max number of names. Okay, int max number of names, and here int number of names is equal to 0. Number of names. Are you with me here? Because that is how okay, let's see how it goes up now. We'll see. Okay, so we are reading one name at a time. And if you think of this one, printf. So remember, I want you to, in one of the classes we discussed about when we are passing multidimensional arrays, that we have to so just out of curiosity, do you want me to write code here or do you want me to write code before and show it to you? Yeah. Percentage. Line 17. Thank you. Awesome. Okay. Now GCC sort names.c, too few arguments. Yeah. So we may need, but for the time being, we'll just leave it like this. Okay. Let's see. Mitansh, Anusha, Shreyas, Varian, Mika, Linda, Nidana, okay. So it is right now, it is just reading and printing the names. And we don't want to keep typing them again. So we will store. So all these names got permanently getting stored in my hard disk. So be careful, guys. Minkesh wants to go for lunch. Okay. Okay, so we just read it from the file and printed on the screen. Okay, so now is the time to dish. So we can break for lunch or spend 10 minutes. And how is sorting happening? Sorting is not happening now. And do the sorting. Let's spend 10 minutes and yeah, let's do it. Okay. If you're hungry, get some snack since you're at home now. So run and get some snack. 10 minutes. So bubble sort. See how the signature timer started, OJ, you are the guys, no? Let's see. So, int number of names. So now, what we want to do is, we want to use a temporary string for swapping strings. For swapping numbers, we have temporary variable, right? Yeah. So I want you to keep, we want to compare the string in row I with string in row I plus 1. What do we do? If you read this man strcmp man page, okay, let's go here and read the man page. Man strcmp. So string compare function, it takes two strings as parameters. And you see how, not on length, on alphabetical order, it takes the base address of two strings. And if the two strings are exactly the same, it returns a 0. And if the string S1, if it occurs lexicographically before S2, that is in the dictionary order, then it returns -1. And if S1 occurs later than S2 in the dictionary, then it returns 1. So between Vinkesh and Patanjali, if you give Vinkesh as S1 and Patanjali as S2, what will string compare return? It will return -1 because your STUE, yeah, so because S1 occurs before S2. Okay. It returns a positive value. Yeah, that's true. It returns a positive value because, okay. V is greater than P. Okay, it returns positive value. You all understood how string compare works? Okay, so now we just have to change this line. But I want you to pay attention here. So string compare, we want to compare two strings, S1, S2. We will see what these S1 and S2 are. If it is less than 0, you want to do. And what is S1? S1 is string row I. How do we access row I? String in row I. This is, and S2 is row I plus 1. Are you with me here? How we are accessing row I and row I plus 1? Because we have to pass the addresses of, we can, but let's say there is a more cleaner way of doing it, but this is, you understand, we are passing the base address of row I and base address of row I plus 1 to string compare function. Are you all with me here? That we are passing the base address of row I and base address of row I plus 1 to the string compare function. And if the string S1 occurs lexicographically before string S2, then it returns less than 0. Okay. So now let's delete line number 37. No, the written values are not difference of ASCII representation. And now we want to swap these two strings. Okay, if that's not the case, we want to swap the two strings. How should we do? Man strcpy. What will string copy function do? It takes two addresses and it copies the string from the source to the string at the destination. Are you with me here? String copy. Copy the string which is present at the source. SRC contains an address. Whatever the string that is present at that address, it will be copied to the address that is present at the destination. Don't worry about that constant? Are you with me here? Okay. Let's say this is the source SRC, and destination is some address. Okay. This address is, let's say, A1. This address is, no, let's say whatever, 1000. So you give A1 and you give 1000. So what happens is, starting this address, the string here, and then there is a null character here. The whole of the strings, these characters are copied to this destination. That's true. RHS is copied to LHS. Source will be copied to destination. Are you all with me here? How is the destination specified? It is like moving the source address. Let's say the SRC is present in one home, and you want to transfer the contents to another home. You want to know the destination address. You will use base address to specify the destination. Source string address, source we specify using the base address. Destination we specify using the base address. And we copy the string that is present at the source to the destination. Are you all with me? Yes, no? What is the key point here? The way we are going to reference a string is by means of what? The way we are going to reference a string is by means of base address. And it keeps on going till we get a null character. Okay, that is the key. So if you're all with me on this one, so let's see. So here, strcpy, sorry, temp str, do you see why we are using temp str, not ampersand temp str? Temp str is already defined. Okay, this is temp str is defined here. Okay, that's it. I think we are good. Yeah, we are basically swapping the two strings. So GCC sort names.c. Awesome. We got our problems. Number of names. What are, why are we hash include string.h? We define temp str on line number 31, right? Temp str contains the base address. GCC sort names.c, bubble sort a, names a. Okay. So now we have to call bubble sort here. Okay. So if it doesn't get sorted, then what happens? You'll not get lunch immediately. Class over. Believe how heartless, Akshat. You are not going to help us solve the problem. Okay, so that's all. Okay, sorry guys, the class got extended a bit. So my so my challenge question for you is this: Rohan's GDP momentum. Rohan, you will get thorough thrashing from your friends if you ask for GDP now. I am also just escaping. So anyway, so I want you to write, replace this strcmp and strcpy. Don't use string.h, you write code for them by yourself. Okay, can you take that as a challenge and solve it? I'll send this code. Don't use string.h, string library, write string copy, string compare code by yourself. You learn quite a bit when you write that code. Okay. Okay then. So that's all I have with you. I apologize for extending the class and